Right now, as you listen to this, you are actually trapped in a bubble.
Yeah, a literal inescapable bubble.
Exactly. I mean, everything you see, hear, and experience around you, it's all a delayed broadcast.
Right.
Like, when you look up at the night sky and point at a twinkling star, it's so tempting to just think, there it is. That is what the universe looks like right now.
Oh, for sure. It feels like a direct window into the present moment.
But today, we are going to completely shatter that window.
We really are. Because it's basically the ultimate optical illusion just played out on a massive cosmic scale.
Yeah.
The universe isn't giving you a live feed. It's essentially a live stream with terrible, completely inescapable lag.
Welcome to the Deep Dive. Today, we're bringing you along on a journey into some truly mind-bending source material.
It really is wild.
We're looking at this incredibly dense philosophical dialogue. It's an actual recorded exchange between a human thinker and an AI.
And they just casually dismantle the very nature of space, time, and reality. Like, no big deal.
Right, just a casual chat. Now, to be clear right up front, we aren't saying this is the new absolute law of physics.
No, definitely not.
We aren't asking you to throw away your science textbooks. Our goal today is just to unpack this author's highly provocative arguments, report on what they're claiming, and basically see the universe through their completely radical lens.
And it's a beautifully complex text to explore, too. I mean, the dialogue touches on everyone from 17th century philosophers like Leibniz,
Yeah.
all the way to 20th century psychoanalysts like Jacques Lacan. And it uses all of them to rethink this grand illusion of time.
Okay, let's unpack this. Our mission today is to decode this really unique physical philosophy.
Because it heavily challenges Albert Einstein's interpretation of relativity.
But, and this is the crucial part for you listening, it doesn't do this by changing the underlying math.
Right. The equations remain exactly the same.
Yeah. Instead, it completely flips the script on what that math actually means for you and how you perceive the world.
Which is such a cool way to look at it.
It really is. So, we aren't going to bog you down in complex algebra today. We're just talking about the literal mechanics of how information reaches your eyes.
Which is, honestly, the perfect place to start. Because the core concept of this entire dialogue rests on this fundamental split between two totally different types of reality.
Okay, lay it on me.
So the source text divides the universe into what it calls global coordinates and local coordinates.
Wait, so there are two different layers of reality happening at the exact same time?
Essentially, yes. Let's look at the first one, the global coordinates. You can think of this as the actual objective electromagnetic field of the universe.
Okay.
It's an absolute flat plane, like a massive XY grid, where every single particle and event in the cosmos exists simultaneously at a time of zero, like t equals 0.
So that's the God's eye view, the universe as it actually is. If you could somehow step outside of it, pause time, and see everything instantly.
Precisely. But here's the catch that the AI and the thinker point out. You are not a god.
Speak for yourself.
Well, okay, fair enough. But no human being can actually look at the global coordinates.
Right.
You are a biological, individual observer trapped in a specific location. And that brings us to the second reality, local coordinates.
And this is how you or me or anyone listening actually receives light and gathers information.
Exactly.
And the text makes a massive point here, right? We do not see that flat global XY plane.
We don't, not at all. The source notes that a local observer actually receives information on what it calls a complex spherical screen.
A complex spherical screen.
Yeah, because light takes time to travel to you from every possible direction, you are essentially standing in the direct center of a bubble. It's a sphere of delayed information raining down on you.
I'm trying to picture the spherical screen practically. Is it kind of like playing a massive online multiplayer video game?
Oh, that's a good way to look at it. How do you mean?
Like the server running the game in California knows exactly what is happening everywhere on the map at t equals 0.
Right.
But I don't see the server. I only see my specific monitor on my desk.
Yeah.
And my monitor only renders what my network lag allows me to see.
That is a brilliant way to conceptualize it, actually.
Huh.
The global coordinate is the server room. The local coordinate is your personal monitor.
Yeah.
You are only playing inside your local bubble of rendered information, not in the objective server room.
Makes sense.
And what's really fascinating here is how the source applies this exact server lag concept to explain one of the most famous sort of head-scratching physics experiments in history, the Michelson-Morley experiment.
Oh, right. Remind me, that's the one from the late 1800s where they tried to prove the Earth was moving through a physical substance in space called the ether, right?
Yes, exactly. The setup was incredibly ingenious for the time. They essentially split a beam of light and sent the two beams at right angles to each other.
Okay.
The logic was that since the Earth is hurtling through space, the beam of light moving in the same direction as the Earth's orbit should be slightly affected by the ether wind.
Like a headwind kind of thing.
Right, it should travel at a slightly different speed relative to the equipment than the beam moving sideways.
But the experiment totally failed, didn't it? Like,
Yeah.
they found absolutely zero difference in the speed of light no matter which way they pointed the beams.
It was a massive failure, but a failure that ended up changing the world. Historically, this zero interference result just blew everyone's minds and led directly to Einstein formulating relativity.
Right.
But the author of our source text argues something highly provocative here. They say that if you look at the astronomer James Bradley's measurements.
Wait, who's James Bradley?
Oh, he's an 18th century astronomer. He calculated that the solar system is moving at about 30 kilometers per second through space.
Wow, okay.
Yeah. The text says if you calculate that specific movement strictly within the local coordinate system.
Meaning you calculate it from the perspective of the player's personal lagging monitor.
Exactly. If you calculate it within that complex spherical screen of received light, the failure of the Michelson-Morley experiment isn't some mind-bending mystery that requires us to invent bending spacetime.
It's not.
No. The author argues it is a natural, mathematically obvious result.
Wait, how does moving at 30 kilometers a second perfectly hide the Earth's movement?
Because of the geometry of how light hits your spherical screen.
Okay.
As you move forward through the light, the spherical bubble of information you are receiving distorts.
Okay.
The text argues that at that specific speed, the geometric distortion of your local screen perfectly masks your movement through the global plane.
That is wild.
Yeah. The zero interference result is exactly what you should expect when an observer is rendering a moving universe on a local delayed screen. It's a localized optical effect, not a universal law.
So if my local reality is just a distorted funhouse mirror and everything I see is a geometric illusion caused by my own movement, that forces us to seriously rethink why time and space seem to warp when things move fast.
Oh, absolutely.
I mean, we are basically overthrowing Einstein's ontology here.
We are. And we probably need to be clear for the listener about what ontology means in this specific context.
Yeah, good call.
Ontology is just the philosophical study of what is physically real, what actually exists in the universe independent of us.
Right.
The text makes a radical claim here. It says Lorentz transformations, which are the mathematical rules that dictate how space contracts and time dilates when you approach the speed of light, are not physical realities.
Wait, hold on. Are you telling me space-time itself isn't actually bending?
According to this text.
Because I feel like every sci-fi movie, every physics documentary I have ever watched has told me that the fabric of space literally stretches and bends like a heavy bowling ball on a rubber sheet.
I know, it's the classic analogy. But according to the argument presented in this dialogue, no. Space-time is not a physical rubber sheet that is bending.
Okay, so what is happening then?
Well, if a spaceship flies past you at near the speed of light, Einstein's ontology says the spaceship physically shrank in length. The author of our text says the spaceship is the exact same size it always was. The warping or shrinking is purely a geometric effect of projecting the light from the front and the back of that fast-moving ship onto your delayed spherical screen.
So it really is just a funhouse mirror effect.
Exactly. It's an optical illusion. And the text points out something critical that often gets lost in physics history, which is that the author's math is 100% identical to Einstein's special relativity.
The math is exactly the same?
Exactly the same. The equations they are running are identical, but the ontology, the underlying philosophy of what is physically happening, is totally different.
That's fascinating.
Yeah. The author actually sides more with the physicist Hendrik Lorentz himself.
The transformations are named after.
Right. Lorentz originally formulated the math for these transformations, but he believed space doesn't actually physically shrink.
Really?
Yeah, he thought it just looks that way in our calculations because of how electromagnetic information behaves.
But let me push back on this a bit because I can hear you, the listener, wondering the exact same thing I am right now.
Go for it.
If the math is exactly the same, and it predicts the exact same outcome for every single experiment we could ever run. Does it actually matter which philosophy we use?
That is a very fair question.
Right, like aren't we just splitting hairs over terminology here? If the math works, who cares if the universe is physically bending or if our screen is just projecting it that way?
It is a great question, but the dialogue makes it clear that it actually matters immensely.
How so?
Let's look at the difference. Einstein's special relativity claims that an observation shift equals a physical distortion of the universe itself.
Okay.
So if your clock appears to tick slower to me, time itself has literally slowed down.
Right.
The author of our text argues that it is just a distortion of our epistemological lens.
Epistemological meaning, the study of how we know things.
Yes, how we gather information. It shifts the focus entirely from the physical geometry of space to the geometry of information.
Oh, I see.
It is the difference between saying, that tree on the horizon is physically only 2 inches tall, versus saying, that tree looks 2 inches tall because of the geometry of my perspective.
Right, right. One assumes the universe changes around you, and the other assumes your vision is limited.
Exactly.
Wow. Okay. That is a massive paradigm shift. But if the universe itself isn't magically bending to give every single observer their own unique, customized timeline, then how do we ever agree on what time it actually is right now?
Yeah, that's the problem, isn't it?
Like if we are all trapped in our own lagging monitors looking at funhouse mirrors, whose clock is the real clock?
That is the million-dollar question, and answering it leads us to one of the most fascinating historical and philosophical arguments in the text.
Okay.
The source states that public time, the universal clock we all seem to agree on, is something we create. It's not something we discover in nature. A global, common time is an institution.
So time, as we experience it together, is totally fabricated.
Fabricated, negotiated, and instituted.
Yeah.
The text brings in Henri Poincaré, who is a brilliant French mathematician working on the mechanics of relativity around the exact same time as Einstein.
I've heard of him.
Yeah. Poincaré argued that simultaneity, the idea that two events in different places are happening at the exact same time, is not a fact of nature. It is a convention. It's a human agreement.
And the source uses the Greenwich Observatory in London as the prime example of this, right?
It does, and the history here is really vital to understanding the physics. Think about the 19th century before standardized time. Every single town had its own local clock based on when the sun was highest in the sky.
Local solar noon.
Right, so noon in London was actually slightly different from noon in Bristol.
Which was completely fine when people only traveled by horse, but
Yeah.
then we invented trains.
Exactly. Suddenly you have trains hurtling across the country at unprecedented speeds.
Yeah.
If every station is running on a different local time, coordinating schedules becomes a total nightmare, and trains literally start crashing into each other on the same tracks.
Oh, wow. I didn't even think about the crashes.
Oh, yeah, it was a real problem.
Yeah.
Humanity was basically forced to invent a unified time, setting a universal clock at the Greenwich Observatory and demanding that the whole world synchronize to it via telegraph wire was an operational, institutional choice.
We even do this with our modern GPS systems, actually.
Well, that's a great point. Yeah.
Like, the satellites orbiting the Earth are moving incredibly fast, so they experience those relativistic optical illusions we talked about earlier.
Right.
We literally have to program our computers to make mathematical corrections just to force the satellites to maintain a common institutional time with our phones on the ground.
Exactly. We continuously do the math to maintain the illusion of a shared now.
Here's where it gets really interesting, though. It's so much like deciding on a currency for international trade.
Oh, I like that analogy.
Think about it. The cosmos does not care about the US dollar or the euro. Those aren't fundamental laws of physics.
Definitely not. But humans create the institution of banking and exchange rates so we can actually interact, trade, and build a society. Time, in the framework this AI and thinker are discussing, is just a cosmic exchange rate we all agreed to use so our local monitors can play the same game.
That's a perfect analogy. We invented the exchange rate of public time, but agreeing on a universal exchange rate is not free.
Right.
There is a fundamental physical barrier to this agreement. The universe essentially demands a fee.
And the text calls this the negotiation cost.
Yes. Let's break down the negotiation cost required to establish this shared reality. Because we and our computers and our telescopes are all permanently limited by the speed of light. We are forever trapped inside our own past light cones.
Okay, let's define that clearly for the listener. What exactly is a past light cone?
Imagine yourself standing in a massive, totally dark field. A past light cone is simply the bubble of light, the information that has had enough time to travel through the dark and reach you from the past. You can only know about an event if the light from that event has finally hit your personal spherical screen. Anything outside your specific bubble is entirely invisible to you.
So my reality is strictly limited to the light that has managed to catch up to me.
Precisely. Now, the source uses a very specific mathematical example to show the brutal cost of trying to share reality with someone else.
Let's hear it.
It uses the timestamp of t equals -10, let's say 10 seconds ago.
Okay.
If you and I are standing far apart in that dark field and we want to scientifically agree on what reality was 10 seconds ago, our verifiable shared reality is only the mathematical intersection of our two past light cones at t equals -10.
So it's a Venn diagram.
It is exactly a Venn diagram. Your light cone is one circle, my light cone is another circle.
Right.
The only reality we can absolutely scientifically agree on without taking anyone's word for it is the overlapping football shape right in the middle.
Yeah, that makes visual sense.
And here is the physical cost. That shared overlap is always narrower, always smaller than what either of us knows individually.
That makes perfect sense because I have information in my bubble from my side of the field that hasn't had time to reach you yet.
Right.
And you have information in your bubble that hasn't reached me.
Yes, exactly. The text actually compares this physical limitation to computer science and distributed system theory.
Oh, interesting. How so?
There is a famous thought experiment called the two generals problem.
I think I've heard of this.
Yeah, if two armies are trying to coordinate an attack, but they can only communicate by sending messengers across enemy territory, they can never be 100% certain the other army received the message.
Because the messenger might get captured.
Right. So in computer networks, independent nodes face a literal transmission cost to verify they've agreed on data. It's known as the impossibility of common knowledge. You have to spend time and energy constantly sending pings back and forth to confirm you both saw the same thing.
But wait, if our shared, mathematically verified reality is always shrinking down to just the narrow overlap of old, delayed information, how do we ever build a complete picture of the universe?
That's a huge problem.
Right. Like, how do we do science or build cities or have a society at all if we can only ever truly verify a tiny fraction of the past?
Well, that exact limitation, that constantly shrinking Venn diagram of verified facts, is what forces human beings to rely on something completely outside the realm of geometry or physics.
Trust.
Trust. To move beyond the narrow slice of overlapping past light cones, we have to accept information that we cannot personally scientifically verify.
See, this is part of the dialogue where I really had to stop and reread.
Yeah.
Yeah, because jumping from mathematical light cones to psychology and French psychoanalysis feels like a massive stretch.
It does seem like a big leap at first.
Like, how does a literal physical limit on the speed of light translate to human trust?
It feels like a leap, but the AI and the thinker actually map it out brilliantly by bringing in Jacques Lacan.
Okay, lay some Lacan on me.
So Lacan developed this concept called the symbolic order. Simply put, the symbolic order is the shared social world of language, laws, culture, and symbols that we all participate in.
Right.
The text states that you cannot build this shared symbolic order just by adding our experiences together. You don't just add my light cone bubble to your light cone bubble.
The text says it's a multiplication, not an addition.
Exactly. It's a product. And multiplying our perspectives requires a profound leap of faith.
Yeah.
The source directly applies Pascal's wager to this problem of physics and information gathering.
Pascal's wager. That's the philosophy where Blaise Pascal argued that even though you can't scientifically prove God exists, it is mathematically a better bet to believe in God.
Right, because the potential infinite gain of heaven outweighs the finite risk of being wrong.
Yes. And the author of this text takes that exact wager and maps it onto human communication.
They do. They argue that it is mathematically and epistemologically a better bet to trust the unverified information coming from outside your light cone, the information coming from other people, because the information gain of trusting them massively outweighs the risk of them lying to you or being wrong.
Which, when you stop and think about it, is exactly what we do every single day.
Every single day.
Every time you, the listener, read a science textbook or check the weather report or honestly listen to this deep dive, you are making Pascal's wager.
Absolutely.
You haven't personally gone into low Earth orbit to verify the curvature of the Earth. You haven't personally built a billion-dollar particle collider to find the Higgs boson.
You definitely do not have the time, the resources, or the physical capability to personally verify the global coordinates.
Right. You take the wager. You bet that the scientists, the journalists, and the historians are telling the truth.
Because you have to.
Yeah, because the alternative, refusing to trust anything outside your own tiny delayed light cone and trying to rebuild all of human knowledge from scratch by yourself, is impossible. You would literally be trapped in the Stone Age.
If we connect this to the bigger picture, it is an incredibly beautiful synthesis.
It really is.
We start with a cold, highly technical mathematical critique of Lorentz transformations and the speed of light, and we end up mathematically proving that the entire edifice of science, the entire structure of human civilization, is physically tethered to our willingness to trust one another.
Wow.
Physics dictates that without trust, your universe remains incredibly, painfully small.
Okay, let's take a breath and just summarize the wild journey we just went on.
Good idea.
We started with a radical geometric critique of Einstein's relativity. We looked at the universe not as a physical bending rubber sheet, but as a delayed, spherical projection rendering on our local monitors.
Right.
We realized that public time isn't a law of nature, but an institutional agreement born out of necessity, just like train schedules and international currency.
Yeah.
We discovered the literal physical negotiation cost of trying to agree on reality through the shrinking Venn diagrams of our past light cones.
It's a lot to process.
It is. And finally, we landed on the realization that overcoming the speed of light requires a foundational leap of faith, a Pascal's wager on human communication and the symbolic order.
It completely reframes what it means to be an observer in this universe. You aren't just a passive receiver of delayed light. You are an active participant in a vast web of trust that literally builds our shared reality.
Which brings me to one final provocative thought for you to chew on. We've established today that objective reality, the global coordinates of science and human progress, are fundamentally held together by a wager of trust between observers.
Right?
It is the necessary glue of our shared universe.
So,
What happens to the laws of our shared reality in an era where interpersonal trust and trust in institutions completely breaks down?
that is a terrifying but honestly mathematically necessary question to ask.
If we stop believing the information outside our own delayed light cones, if we refuse to take Pascal's wager on each other, does our shared universe literally shrink?
It seems like it would have to.
Do we devolve back into billions of disconnected, lagging monitors, unable to agree on what game we're even playing? When you step outside tonight and stare up at the night sky, you aren't just looking at delayed light. You are looking at a massive cosmic system that physically requires you to trust the person standing next to you if you ever want to understand it. Something for you to mull over until next time.